So the technologies themselves, the networking technologies, when they were created first, like the very basics before complications were there, they were divided from the beginning to multiple layers of techs or of technologies. Each layer is different from the other one in the technology itself, what's happening in that layer. Let me tell you something, like a car engine or like the entire car chassis with everything of the components. You have like the engine itself, some parts of the engine only related to kerosene or gasoline, depends on the car or depends on how they are operating. Other parts are only related to oil. Other components are related to the, what do we call that, the coolant water. I forgot about that. Blue, the green, sometimes orange colored radiator water, that radiator liquid, cooler liquid that can bear up to 140 degrees, and it will not, let's say, start to evaporate at that temperature, etc. Each component has its own operations, but of course, in the end, all of them must work together to achieve a fully healthy car that is running, if you want to do it in that way. Sometimes you don't need all of them to run. Let's say sometimes you can achieve something, but you don't need all of the components to participate or to be operating at the same time. Like when the weather is good, you do not need to operate the AC, the air conditioners. Thus, you have an entire components, one, two, three, sometimes perhaps five components of the AC that are completely off. Yet the other components are running and you are having a nice time driving. So there are some components, each one of them is doing something different from the other, but they are still related in the end to achieve one single target. When they came to networking, they divided that basically to 7 different layers. Each layer have different technology, different things or operations running inside it, so that in the end it will deliver that summary lovely format to the next layer, to the next layer, to the next 7th layer. In the end, the 7th layer at the bottom will connect you to the other device, and the other device will do a reverse process that I will talk about in a minute, and the result will be the other device simply will receive a PDF file that you sent via the email from your computer to the other end. So the I'm sorry for that. The Open System Interconnection model, the OSI model, is the model of the first model of the network architecture models that we are about to talk. There are only 2 that I will talk about today, and the only 2 that you need to know. And just for the record, these 2 models, the network architecture models that I will talk about in this video, are out of the agenda of the course. Why? Are they mandatory? Well, they were mandatory. Well, like, let me tell you, 99.9 of the engineers before 2020 knows what an OSI model is. And even the other one, the TCP/IP. They must, let's say it's the ABCD. Like, you can't skip that part. Your entire, you feel, but not really. You feel like the entire career, you will be like ashamed, like they will bully you later if anyone knew in the community that you have no idea about the OSI model or the TCP over IP model. Until Cisco in 2019 stated the agenda that no CCNA engineer has ever really did something troubleshooting or developing or designing to the network or affected the network using the technologies that are mentioned in the OBS or in the OSI chapter. Like, you're still feeling like, what? Well, I will just brief the 2 models in this video. I will not take a lot of your time, but seriously, you will walk throughout the course. You will finish chapter 1, 2, 3, 4. You will feel like a lion after chapter 4, really like a champion. You can do so much things, so much talking, like a year of college, like in 4 chapters. You can do so much things right now or real life with devices, all of them available in real world life, in the real world life, that just like in the course. Everything that I mentioned in the course 100% is available worldwide in all of the networks, so nothing is rubbish, nothing is extra, but you'll find that even if I did not know about the OS, I might still have survived without not affectness. Yes, can be done in that way. That's why Cisco has removed the OSI. And by the way, you can Google something called CCNA 200 125 versus CCNA 200 301. You can see ton of topics that have been removed from the old CCNA, and most of them I know instructors that are still right now from 2019, from June 2019, the day of announcement of the new course CCNA, until now June 2021, 2 years, they are still crying, seriously crying for the topics that Cisco has removed. Move on, leave the old school, please leave the HDLC, please leave the PPP, leave the OSI, TCP/IP, leave the RIP. This is killing me. I'm serious about the ton of courses available on YouTube, the ton of courses that are available on other institutes. They are talking about the routing information protocol. Something has been obsolete since the 90s. And Cisco shouldn't have even done that in 2014. They did, but they removed that in 2020, and it should be removed. But no, some instructor says no, this is the old black magic, you need to study it at all. So I just gave you some extra headache at the beginning of this video. But sometimes, yes, be careful when you read something in the agenda. When you see how the agenda is designed, you can stick with the agenda. If you wanted to learn more, learn something like evolutionary, like segment routing, mastering IPv6, of course SD-WAN and SD access, blockchain, so many things. Juniper networks, don't neglect that. Arista and Aruba might be very useful in the future. Depends on your environment and the inventor there, but don't waste your time on a lot of OSI, TCP/IP, RIP, not the RIP, please, not HDLC, not the old-fashioned at all. Okay, so the open system interconnection model, this one has 7 layers, and I will start from top to bottom. Why? Because this is what you are doing right now every day without you notice, because this layer is called the application layer, that holds the layer that holds the application that you are using right now. Let me assume that you have a computer that is running Microsoft Outlook, the Apple Mac mail application, the Microsoft Windows mail application, whatever other mail application that you are using, Gmail over the, let's say Gmail over the browser, still the browser like Google Chrome or whatever, Firefox, Opera, Internet Edge, Microsoft Edge, all of these are applications. So you are running application number one. So you are using something every day that runs on the 7th and final layer on the top of the OSI layer. At that layer, you are using the applications like Google Chrome, Outlook, etc. And whatever you are doing is called datagrams. Later on, you will study something called API as well. And let's focus on datagrams right now. So datagrams, it's what's being there. Number 2 is when you are seeing things by your own eye. Okay, I have launched Outlook, and in Outlook I received a PDF file. I double clicked on that, and the Adobe Reader, because I'm using like Adobe Reader, have launched that PDF file for me. So now I'm reading that portable document as PDF. And now I have moved in from layer 7, the application of Adobe Reader, to layer 6, which is actually, I'm still in layer 7, but I'm making use of 2 components at the same time, layer 7 and layer 6, because right now layer 6 is the presentation layer. And really simply, this layer is all about .pdf, .jpg, .png, so many other things, docs for Microsoft Word, .ppt for the PowerPoint, and millions other like formats. So layer 6 is responsible of presenting to you that file in the correct shape format, so that you will see it as the portable document format, PDF, the portable document format. So you are seeing it that way. So that happens at layer 6. But of course, with the cooperation of layer 7, I am able to run an application after I downloaded that PDF from the application at the first time, which was like Microsoft Outlook. So I'm making a good investment with from layer 7 and layer 6, and now we move down to layer what? To layer 5. This layer is responsible for establishing a session between you and another application, another or remote application on another computer. Like, let's assume right now a different scenario where you are receiving or you are sending a PDF file via the Outlook to your friend on the other side that is also running Outlook and waiting for your PDF file to be received to the other end. So you will use layer 7 to run the application of Outlook, and you will use layer 6 to represent that file to be sent as a .pdf, and you will go down. Now you are going downward until you reach layer 5 to establish a session between you on the other end. Good. So you have established a window from your computer, from your connection to the other end, and then you move down until you reach something called the transport layer, where there you'll have to establish, or you have to choose, something called the destination port and the source port. If networking was like 60 years ago, I was not alive at that time, but I believe what I understood that at that time, if there was nothing called the transport layer and the transport layer 4 ports, by the way, this is the 4th layer, then what would happen is that you will only be able to run one single operation at a time through the network, like only receiving an Outlook email, and that's it. But seriously, yeah, I'm sorry for that. Nowadays, what's happening is simply millions of operations or hundreds of operations or thousands at a time on your computer. You can download files while you are using Outlook, while you are browsing the internet at the same time. Perhaps you are uploading to youtube.com a video just like the video I'm recording right now, and I will upload later when I end recording. So tens or hundreds of operations at the same time, all of them through the internet, all of them without overlapping, thanks to layer number 4, the transport layer, that will take every single operation, every single application, every single protocol and feature, and will specify a port for it. So ports are 65,536 in total, but they start from 0 up to 5 up to 65,535. The last one will be 5, so 0s counted, 5s counted, making it a total of 65,536 ports. The first 1020 4 ports are reserved for the famous applications, etc., that I will talk about throughout the course. That will be important. But the idea again is that you can do so many things at the same time. You can communicate so many things and send so many different applications at the same time over the internet, thanks to the different thousands of ports that can be established from the session using the destination transport ports from layer 4. After that, you'll go down to layer 3. In layer 3, you will have to create a packet. Inside the packet, there will be something called your source IP that you are using to send, the destination IP, which refers to the destination address of the person that you want to, just like a real address. Some guy carrying the mail, and knowing your source based on the post, you're knowing the destination so that it will deliver to that destination. And this is how things are done. When we will talk about more about that much more later, but actually it's only removed from the agenda, so I'm only briefing that to you without extra headache. After that, we move down to layer 2. In layer 2, my packet will be encapsulated inside a big frame that is called the frame, the layer 2 frame. In the layer 2 frame, something called MAC address that will have a video for it will be assigned, labeled on the frame, destination MAC address of the other guy, source MAC address of me, and it will continue to go on, and finally it will go down, and all of these info will be converted to bits, ones and zeros. Everything participating in the physical layer is a physical thing. Your router and the cables that are connecting the router to the other end, to the other router, and so that the other router will receive, if it was like a copper cable, I will have a video for that, of course. You are sending electricity waves from your source to the destination, and in that way you are transmitting those bits, ones, zeros, 11100 10001110. In that way, you'll continue to send all of these. You are representing all of these on the matter of ones and zeros so that it will reach the other end. The other end will combine or will collect all of these ones and zeros, and then it will find the frame. After it finds that architectured frame, it will open it. Inside it, it will find the packet. Inside the packet, it will see the destination port, and then it will go to the session and up until it reaches the application, and on the other end your application will show that .pdf. Things can be written in a book of 1,000 paper when we'll talk about that, 1,000 page, but we only brief that since it's out of the scope, out of the agenda, and that should be good. And later the TCP IP model was actually summarized to be simpler, because the last three top layers are actually development things or programming stuff, not for network engineers, so they will all represented as application. The application will show the PDF, the application will run itself, the application will start the session, whatever, so all of them will be application. Transport is still transport. Layer 3 became the internet, and layer 1 and 2 became both of them the network access, because you will need the cable, you will need the router, you will need the physical address of the routers on both the ends with that cable to access the network. So let's make them network access. So that would be the TCP IP, transmission communication protocol over internet protocol, TCP over IP model. Less specific, still some layers go through encapsulation. Decapsulation, yes, you will need encapsulation from 4 to 3, 3 to 2, and vice versa. There you need it from 4 to 3, 3 to 2 to 2 to 1, and vice versa as well. So that should be just a very brief introduction regarding the TCP over IP and the OSI model, and that's it. But let's say throughout the course I might mention them, I might talk about them, I might tell you this is a layer 3 issue, this is a layer 2 issue, whatever. But still in this very chapter, in chapter 1, I will still go through source IP, destination IP. I'll talk about that in chapter I'll talk about IPv4 and IPv6, so I will tell you what an IP is. I'll talk about MAC addresses, so I will tell you what a MAC is and why we mentioned source MAC and destination MAC. So a lot of info, because 7 hours for the first chapter is not something like can be done in a couple of videos, not of course. So I hope that everything was clear for you. I hope that I did not give you so much headache, and I hope that we will continue in the upcoming video. Thank you.